Okay. Hi, everyone. Welcome to EECS 494, discussion number 7 for the winter 2021 semester. Um, this week, we're moving away from asset creation things and things like that. And because we're in the first week of Project 3, I wanted to share a short presentation with you called Project 3 Tips I Wish I Had at the Beginning. Essentially, this is a sort of compilation of things that I learned when I did Project 3 in EECS 494 that hopefully making you aware of this at the beginning of the project will be helpful for you. So let's get started without further ado. All right, so first things first, Unity logistics. Um, don't upgrade Unity versions during Project 3. Agree on a single version of Unity to use on your whole team and just stick with that the whole time. Um, my team, I don't remember the details. We had some problems with the current version of Unity that we were using. We decided that we would, as a group, collectively agree to upgrade Unity versions, and we lost nearly a full week worth of work uh, because we were spending so much time fixing bugs and like figuring out like problems that arose by trying to upgrade Unity versions halfway through the project. So for the sake of preventing headaches and saving you time, just stick to the same version and don't change versions partway through. That's my first tip. The next Unity related tip. So apart from versions, there's also, you may have seen that there are different things called render pipelines. Render pipelines simply refers to the back end that Unity is using for its rendering your game onto the screen. Um, Default 2D and 3D projects use something called the built-in render pipeline, which works pretty well for everything you need to do. We used the built-in render pipeline for Project 1. Most of you probably used it for Project 2 as well. Um, but if you want to do, say, for, juice, theming, or professionalism, you want to use Shader Graph, which is Unity's system for writing shaders without code. You can essentially write shaders as nodes on a graph. And each node is a different effect, and then you can apply a bunch of effects all at once together and create really high quality materials. If you want to do something like that, for example, um, you can't do that in built-in render pipeline. So if you want to have the ability to use shader graph when you're working on your project 3, better to do this earlier rather than later. You can install the universal render pipeline, which is one of the render pipelines that supports shader graph. You can install it into an existing project that's using the built-in render pipeline. I will link this in the description of the video here. This is a tutorial on how you can install URP into built-in render pipeline. Another document here is a comparison between URP and the built-in render pipeline. There are, a couple differences between the two, so you can compare them, but the biggest thing for you to know is that URP supports shader graph and HDRP, that built-in render pipeline doesn't. So that's really the main consideration. There's another render pipeline that supports shader graph as well called the high definition render pipeline, or HDRP. And you may be wondering, why not HDRP rather than URP? There are a few reasons. The biggest one is that, as far as I know, HDRP still doesn't support 2D projects. So, if your game is a 2D game, you can't use HDRP. You're stuck to URP for shader graph games. The second thing is performance. HDRP is sort of designed, it's called high definition render pipeline because it's sort of intended for, making really high quality looking games that are going to be running on the best hardware. So, PCs designed for gaming, or Xboxes or PlayStations. Um, and there's a chance that if you make a game using HDRP, you may introduce some performance issues for your fellow classmates when they're playtesting your games, as opposed to the universal render pipeline, which is about just as performant as the built-in render pipeline. They have about the same performance, and yeah. So it a couple of reasons, but essentially, if you want to go with shader graph, I would highly recommend URP instead of HDRP. Cool. All right, next slide. This is in regards to source control and merging. Um, Austin talked about this during lecture when he talked about working in a team. But I can't stress this enough how much easier this makes things. Create separate scenes for each team member. That's like just gonna make things so much faster, so much easier. Just don't make sure that you're communicating and making sure that everyone isn't working on the same scene at the same time. On top of scenes, make sure people aren't, making this modifications to the same scripts too much at the same time. Those can obviously still be merged pretty easily, but it's still, the more you communicate about who's editing what, the better things will work out when you merge. And then in regards to that, submissions, your weekly submissions for Project 3 will be on Mondays. I would recommend thinking about, starting to merge everyone's work together on Saturday or early on Sunday, because the more you put this off, you have the potential essentially to end up pulling an all-nighter, because things can get out of hand pretty easily in terms of integrating work. If someone made a mistake or things got modified in such a way that things got broken, you can never predict if merging people's work together is going to break your game. So better early rather than later to start integrating everyone's work together. I have a couple tips in terms of doing this sort of merging, where you have each person's personal lab scene and you're merging into the single master scene that, is what you're using for your main game. Start with scripts, merging, if people have been working on the same script, you can merge that together using something like Git or a merge tool. If people wrote different scripts, you can just add all of those together. The IDE will check for compatibility errors, if people have changed up interfaces, if they've changed what public variables are available, things like that. Visual Studio or Visual Studio Code or Xcode or whatever you're using will tell you, if there are problems with your scripts. Once you deal with that, then next I would recommend assets like images, textures, audio files, sprites, video files, whatever you have. I would recommend those next. And then finally, I would suggest dealing with prefabs and game objects and placing game objects in your scene properly. I would suggest going with that last. This is sort of like a logical order that I suggest makes your merging go a little bit more smoother. Yeah. Enough about source control though. So the next thing I want to talk about is control schemes. So as all video games are, your game that you make for Project 3 will need to be controlled by players. To that end, please think about this early. Think about the control scheme for your game early, and whenever you make changes or add new game mechanics, think about the controls for it as well as the mechanics. It can be easy to sort of just pick a throwaway key or a throwaway control scheme initially when you're focused on mechanics. But the earlier you decide on an easy and accessible control scheme, the better things will end up for your team. It'll just make it a lot smoother. It'll make creating the tutorial easier. Remember that you'll be graded on guidance, and you might lose points if your guidance isn't good. So a couple things to keep in mind when devising and coming up with your control scheme is making sure the player doesn't have to move their hands at all very much. So a mistake that a lot of people tend to make is they'll have a mouse and keyboard game where the player's right hand is on the mouse and their left hand is sitting near W, A, S, and D on the keyboard. And then they'll use something like M or P for map or pause, or they'll use I for inventory. And if you look at your standard keyboard, I, P, M, these keys are all on the right half of the keyboard. And the person, if you're a mouse and keyboard game, a person's left hand is going to be all the way on the left hand of the left half of the keyboard. So those are kind of no-nos. They're kind of faux pas that, a lot of professional games end up using this as well, but it's tough, and it causes a lot of, I guess, difficulty and discomfort for the player if they have to constantly look down away from the screen, move their hands, and click on certain keys to do something. That's not great. So you can, think about using the number keys, Q and E. Shift is great. Escape for pause is better than P for pause. Tab is a great key that a lot of games use for map rather than M. So I would suggest, in terms of that thinking there, in terms of some of your games, some of you might make games that don't require mice, so it might just be a keyboard only game. In that case, make sure you design your user interfaces to also not require a mouse. A mistake that we see a lot of teams make is their game will be an arrow key based game, and then in order to click play or, click next level, the player will have to move out from their, position on the keyboard and go to the mouse and then click on buttons. It's fine, but it's not great. So we would suggest making your UI and your menu not use a mouse if your game doesn't use a mouse. There's no reason for one to require it and the other to not. The next thing I want to say in terms of controls is related to sort of tropes or common things that are used for controls. If you're using a WASD based movement scheme where, right hand is on the mouse, left hand is at WASD. E is a great key that a lot of people use for interact. A lot of games it's sort of like a standard in the industry to use E for interact. Q is also a common one for interact. F for another function. R is used for reload in games with ammunition. And then, again, the mouse is used for camera movement with left click and right click. If you're using an arrow key based movement scheme where the right hand is the arrow key and it's moving the player around, and then the left hand is doing different actions, you tend to see Z, X, and C being used as action buttons. You used these in Project 1, Z and X, I believe. So that's a very common thing to do. Z and X, and they're all kind of very close to each other. And finally, of course, space to jump. That's a very common one. Sort of any control scheme you have, whether it's arrow keys or WASD with mouse, space is kind of universally agreed in the industry to be the jump key. So we would suggest not confusing the player by making space something else if your game has a jump. Another thing is I'll share the slides to this in the description of the video. If you're thinking about adding optional controller schemes to your game, remember that mouse and keyboard scheme is required for controlling your game, but a controller isn't required. If you want to have a controller and you want to map your mouse and keyboard control scheme into the controller, I basically have some advice for mapping these. I'm not going to go over this too specifically because this isn't a requirement. This is just a sort of optional thing. The next thing I want to mention, moving on from controls, is camera movement. So, one thing that can be kind of difficult to deal with in Unity is cameras. It was sort of a non-trivial part of Project 1 for you guys with room transitions. It continues to be a sort of difficult thing for you you to deal with in your projects. I have sort of like a list of a couple very common camera schemes that you can see in games. And like sort of the controls for the camera that people tend to see. So with like third person 3D games, you tend to have either the camera goes in the direction that the player is looking. Um so, if the player starts to go is going forward and the camera is behind them and then the player turns right, the camera will automatically turn so that the player is moving forward in the camera view. Um that's sort of a follow player movement sort of camera scheme. Um the other thing that you see some games do is complete camera control to the player, and that's uh, a game where the mouse is used to completely control the player. Moves the mouse around to turn the camera, and it stays wherever when the player moves. It just stays where the player has positioned the camera. It's not like moved automatically. The third option is sort of a hybrid of both. Mario Sunshine is an example that I put here, where if the you know if the player isn't moving around, they can use the camera and move it around themselves manually. There are certain modes, like certain game mechanics, where the player is given full control of the camera, like when in Mario Sunshine the player shoots with the water gun. But when the player is just moving on their own and they're not trying to move the camera on their own, the game sort of decides the best camera position for the player. So it's you can consider it a hybrid where if the player isn't making a choice, the game makes a choice for you. This doesn't work in all games, but it is one of the options that you see. In terms of 3D first person games, you probably always want to go with complete control of the player. You don't want to be moving the camera around automatically unless it's like a cutscene for a first person game. That tends to just be very disorienting and not very sort of canonical or standard for first person games. In terms of 2D games, you have the camera following the player around the stage, which is sort of a Mario thing, where it moves in all directions around with the player, like in a top-down game or even like a side-scrolling game. There's the other thing where you're fixed in one dimension. So, old Mario games, the original Super Mario Bros., the camera couldn't move up or down, it only moved left and right. This would be a camera like that. Certain games want to be designed with a fixed height in mind, and then the width is all that scrolls, and that's another potential camera screen. In any case, what I mean to say by all of these examples is that there are a lot of options for how your camera can work in your game, and deciding this early can really affect the feel of the game. So I would highly recommend thinking about this, as soon as possible. On the note of camera stuff, there's this built-in package for Unity called Cinemachine, which you can install using the Unity package manager. It's really great. It's a great sort of plugin for Unity to make camera work a lot easier and smoother than just what you have built in. I would really highly recommend checking it out and trying it out if you want to have a very smooth camera. It does have a little bit of a learning curve to learn how it works, but using Cinemachine tends to... A lot of teams have found success in previous semesters using Cinemachine. So I'll put the link to that in the description of this video for you to check out. Yeah, next slide. Research. So like the first two game projects, Project 3 has a research assignment. I would suggest trying to do this sooner rather than later, just for the reason that the games that you play for your research can give you a lot of great ideas for game design. They can be very sort of inspirational and helpful in you sort of informing how your game is going to be designed in things like, I just mentioned control schemes and cameras. This is a great way to get more information and like brainstorming on how you can go about your camera and control scheme is by doing your research games early. um Game mechanics, tutorialization, the doing your research. The sooner you do your research, the more impact it will have and the more helpful it will be for your game. If you do it later, closer to when it's due, like your game might have cemented a lot of things already, and any good ideas you get out of your research assignment might not be possible to integrate anymore. Um, which isn't, you know, it's not all. It's always kind of crummy feeling where you have a really good idea, but you can't go with it because your game's already going in a different direction. So yeah, get on research early, think about it, play these games, get good ideas. Highly recommend it. I think I have one slide left. Yep, the last slide I have here is don't leave the tutorial to the last minute. Um, keep your tutorial, kind of keep working on a tutorial as you go on in the game or in your work. Sort of keep a running tutorial which you keep up to date as you add and remove controls. Um, we one of your grading things on the rubric that we grade you on every week is your guidance, and you're gonna lose points on guidance if you aren't sort of thinking about how to teach your game mechanics to your players. So I mean I would suggest again, rather than having to put a lot of time later to just like make a good tutorial, start thinking about it early and make a little bit of incremental progress towards your tutorial every week to make it, keep it up to date and fresh. It can even, in a lot of games and a lot of examples, your tutorial can be the first level of your game, um, or it can be the first part of the first level of the game. It definitely worth it. So that's the sort of last tip I had on the slides here. Um, yeah, I think that's all I had to share with you. I know that's a lot to think about. The link to these slides will be in the description. Like I mentioned, the link to all this other stuff that I talked about will also be in the description. Um, and yeah, I hopefully these tips were somewhat helpful and they'll help inform some of your initial decision making as you start your game. Um, I'm excited to see what games all your teams are going to make, and I'm hopeful that Project 3 is going to be successful. Good luck, and yeah, have a great weekend.